Let us begin by reading the word problem out loud. Robert wants to put fencing around his rectangular yard. The length of his yard is 15 feet longer than the width, and the yard has a perimeter of 130 feet. Find the length and width of his yard. Let us begin our strategy for problem solving by analyzing the problem. Keep in mind that the first thing you want to do when analyzing the problem is to identify what it is we're asked to find. In this case, they want us to find the length and width of his yard. So the keyword being and, so there's two things we want to find, the length and the width. So that means we're going to have two unknown variables. So let us go ahead and assign those variables. So we'll let x equal the length and y equal the width. So now that we've assigned a variable, let's just go back to analyzing the problem. So let's see what information we can extract. Well, for starters, we know that his yard is rectangular yard. So we know we're working with a rectangle. So that's very important. And then we also know that the length of his yard is 15 feet longer than the width. So we have a relationship between the width and the length. So the length is 15 feet longer than the width. And the last part of it talks about the perimeter. So the yard has a perimeter of 130 feet. So we're going to be using the 130 for perimeter. And then also going back to what was in blue, let me go ahead and circle the 15. So there we go. Those are the key things that we could actually extract from the word problem. So now let's go ahead and start forming an equation. So I'll start off by drawing a rectangle, since we are working with a rectangular garden. So there's a rectangle, representative of the rectangular garden. And it's going to have a length, which is represented by the variable x, and a width, which is represented by the variable y. So there we go. So now what do we know? We know that the length is 15 feet longer than the width. So we have a relationship between x and y. So I'm going to go ahead and start by creating an equation with the variables x and y. And now it says that the length is 15 feet more than the width. So the length is represented by x, and x is larger than the width. So if we want this equation to be equal on the left as it is on the right, we're going to have to add 15 to the smaller, which means we're going to add 15 to the y. So let's verify this just to make sure. The width is smaller and the width is y, so if we add 15 to that, we should get the bigger, which is x, or the length. So yeah, makes sense. So now the last part says that the yard has a perimeter of 130 feet. So we actually know a formula for the perimeter. The formula for the perimeter is 2x plus 2y. But now we actually know that the value of the perimeter P is 130. So that's going to give us our second equation. So I have 130 is equal to 2x plus 2y. So there we go. Those are going to be our two equations. So now let us go ahead and solve the equation. We'll start off by writing them down. So we have x is equal to y plus 15 for one equation. And the second equation is 130 is equal to 2x plus 2y. So these are going to be our two equations. One thing you want to notice is that the x is already completely by itself and isolated on one side of the equation. So this sets us up perfectly for a substitution. So we're going to go ahead and substitute that into the second equation. So we'll have 130 is equal to 2 times x. However, we now have that x is equal to y plus 15. And then we still have plus 2y. So we're still going to have 130, so we'll bring that down. And then once we distribute the 2, we're going to end up with 2y plus 30. And we still have the plus 2y at the end. So now simplifying down on the right hand side, we'll have 130 is equal to, well, 2y plus 2y gives us a total of 4y. And we still have the plus 30. So what we want to do here is we want to get the y again completely isolated and by itself. Right now we're multiplying it by 4. And then after we multiply by 4, we're adding 30. So what we're going to want to do is subtract 30 from both sides. So let me go ahead and write that down. So there we go. We subtract 30 from both sides. And now on the right hand side, the positive 30 and the negative 30 cancel each other out, leaving us with just 4y on the right hand side. And then on the left, 130 minus 30 gives us just 100. So now we're one step away from getting the y by itself. Right now we're multiplying it by 4. We want to undo multiplication. The way we do that is through division. So we divide both sides by 4. On the left hand side we end up with 25, and that's going to be equal to y. So that's going to be our solution for y. So now that we know the value of y, we're going to go ahead and substitute that in to the first equation and find our value of x. So we're going to have x is equal to y, which is 25, plus 15. So we end up with x is equal to 25 plus 15 gives us 40. So now we know the value of y and x as well. So we have solved the equations. Now let us go ahead and state the conclusion clearly. Keep in mind that we were asked to find the length and width of his yard. So we're going to go ahead and state the conclusion as follows. So we're going to go ahead and write simply that the length of his yard is 40 feet and the width of his yard is 25 feet. So now let us go ahead and check the result. So we'll start off by bringing down the equations. So we're going to have x is equal to y plus 15 for the first equation. Then we're going to have 130 is equal to 2x plus 2y for the second equation. Plugging these values in for the first equation, we have 40 is equal to 25 plus 15. So we do end up with 40 is equal to 40. So that verifies that our first equation is correct. And now following through with the second equation, we're going to have 130 is equal to 2 multiplied by x, which is 40, plus 2 multiplied by y, which is 25. So we end up with 80 plus 50. And that is indeed equal to 130. So we end up with 130 on the left is equal to 130 on the right. And this verifies that our solutions are both correct.